So for the last 10 minutes of class, I want to introduce hypothesis testing for the mean. So before I go through an example, I just want to do a recap. So for the past few weeks, we've been dealing with sampling distributions, we've been calculating confidence intervals, and we've also been doing hypothesis tests for proportions. So we want to build on these ideas right here in order to do testing for the mean. So let's just read through this example right here, and as I read through it, I want you to pick out key information, and I want you to think about how you can use this key information to test for the mean. So this example states, a coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. In a sample of 20 cups, we found a sample mean of 9.845 and a sample standard deviation of 0.199. Is there evidence that the machine is shortchanging customers? So on this handout I've provided you, I have listed some steps, and the first step, it says identify the given values in symbolic form. So this is very similar to what we've been doing. So we want to list the given values. So to start out with, we see that we're supposed to get 10 ounces of coffee. So we could say that the population mean, mu, is equal to 10. And then it says that in a sample of 20 cups, so that tells us that we're dealing with a sample size of 20, and we denote that by n. So n is equal to 20. And then it says we found a sample mean of 9.845. So sample mean we denote by y bar. Y bar is equal to 9.845. And then it says a sample standard deviation of 0.199 was found. So S is equal to 0.199. So we want to use this information in order to go about testing our hypothesis. So the next step I have listed there, it says identify your claim and write the null hypothesis and the alternative hypothesis. So what is our claim for this problem? What are we claiming to be true? Well, we're claiming that the machine does indeed give us 10 ounces of coffee. So we say that mu equals mu naught, the true mean, which is equal to 10. That is our claim. So now we want to write out the null hypothesis and the alternative hypothesis. So for the null hypothesis, remember that the null hypothesis, must contain equality. So if it contains equality, then it's equal to something. So we're saying that our null hypothesis, what our claim is equal to 10 ounces of coffee. We should be getting 10 ounces of coffee. So our null hypothesis is equal to 10. And then our alternative hypothesis, well, if we don't get 10, then we either get less than or greater than 10 ounces of coffee. But we're trying to show that the machine shortchanges the customers, so it needs to be less than. So the alternative hypothesis is less than 10. So is this a one-tailed test or a two-tailed test? Yeah, it's a one-tailed test because it's less than. And it could be greater than, and then we would still be dealing with a one-tailed test. But in this case, we're just dealing with less than, and so it's a one-tailed test. And there are two-tailed tests. We've seen plenty of examples of those where we have the alternative hypothesis not equal to whatever value we get. And so thinking about our assumptions and conditions, we're trying to figure out where to go from here. Well, our assumptions and conditions are the samples random? We'll assume that they're random. We'll assume also that the samples are independent of each other. And we'll assume that the data here, that the data given, follows a nearly normal model. And with the 10% condition, we'll just do away with that because we are dealing with a small sample, so we can just neglect that condition. So since we are dealing with a nearly normal model and all of the assumptions and conditions are met, then we can go forward with a normal model. But why can't we continue with a normal model in this case? It's because sigma is not given. The population standard deviation is not given, so we need to think about another way in order to test our hypothesis right here, to test our claim. And to do that, we've been talking about the student T model. So the student T model with n minus 1 degrees of freedom is also known as what distribution? The t distribution. So with this t distribution, with this data, we know we're dealing with 19 degrees of freedom. So this allows us to construct a one-sample t-test. And with this one-sample t-test, we're going to be calculating a t-statistic of n minus 1 degrees of freedom. So we have a t-statistic of 19 degrees of freedom. And the formula follows y bar minus mu naught, which is our true mean, divided by the standard error of y bar. And we know that the standard error of y bar is equal to the standard deviation divided by the square root of n. So using our given values, substituting those into this formula, we get 9.845 minus 10 divided by our standard error, which is the standard deviation of 0.199 divided by square root of 20. Putting this into your calculator, you should get an approximate value of negative 3.483. So with this value right here, we can leave off the negative, we can neglect the negative. So with this t-statistic, we need to look in the back of our book in order to find the associated p-value, or the probability, just like we've been doing with z-values. So looking in the back of the book on page A-108, we have at the top here two-tail or one-tail probabilities, and we're dealing with one-tail. So we're trying to find which p-value we're dealing with this particular problem. So here we have the degrees of freedom, so we're looking for 19. So we're looking at this row right here. So on this row right here, we need to look for the associated t-value that is closest to our calculated t-statistic. So we're looking on this row, and we get to 2.861. This is the closest one to our calculated t-statistic, and that is 2.861. So the corresponding p-value is 0.005. So this is telling us that our exact p-value for this one sample t-test, or for this hypothesis, needs to be less than 0.005 in order to reject the null hypothesis. And putting our t-statistic of 3.483, and then our degrees of freedom, and then one tail, putting this all into Excel gives an exact p-value of 0.001225. So this exact p-value, which we'll have more practice in next class to calculate these exact p-values with Excel, we see that this is smaller than our p-value given in the book. So this is saying that we can reject the null hypothesis, which tells us that there is strong evidence to suggest that the machine is gypping customers on their coffee. So we'll talk about calculating these exact p-values in Excel and some more topics in the later class. Thanks.